Hello everyone. Today we'll discuss about the nomenclature of alkenes and alkynes. The first rule is whenever a double bond or a triple bond will be given to you, first of all identify the longest chain with the maximum number of unsaturated bonds. I repeat, the longest chain with the maximum number of unsaturated bond. We have got a compound 1, 2, 3, 4, 5, 6, which means hex. After that, for double bonded compounds, you will end with "-ine". For triple bonded compounds, we will end with "-ine". Now, since this is a double bonded compound, we will end with "-ine". Now, which side to start the numbering? We'll use the lowest locant rule. The second rule is the lowest locant rule. We'll start from that end where we will get the double bond or the triple bond with the least locant. So 1, 2, 3, 4, 5, 6. So hex, 2, in. Hex, 1, 2, 3, 4, 5, 6, hex. Then 2, because the double bond is starting from the point 2, and since it's a double bond, we'll end with in. If it's a triple bond, we would have ended with "-ine". Moving to the next one. Now in this compound, first of all, 1, 2, 3, 4, 5, 6, hex. It is the total number of carbon. Now see, I have given you double bond as well as triple bond. Now when the locants of double bond and triple bond are different, locant means the position from which it is starting. When the locants of the double bond and triple bonds are different, irrespective of their nature, you will look at the locants of these multiple bonds. Means, see, if you start from this end, the double bond is starting from 1, 2, 3. If you start from this end, the triple bond is starting from the first position. So whether it is a double bond or whether it's a triple bond, we will give priority to the locant. So since triple bond is starting from the first carbon, we will give 1, 2, 3, 4, 5, 6. So from 3 we have "in", and from 1 we have "-ine". Alphabetically, E will come first. So 3 "in" and 1 "-ine". Now, if I consider this one to be the first part or this one to be the last part, if your last portion, the final one, is starting with A, I, O, U or Y, if your last portion is starting with A, I, O, U or Y, never end the immediate portion of it with any vowel. I repeat, if your last portion is starting with A, I, O, U or Y, you will never end this part, the immediate portion which is written in front of it, never end that part with any vowel. So we'll skip out this E and the name will become hex 3 in 1 "-ine". Moving to the next one. Now in this compound, if we start from the left side, the double bond is starting from the second carbon. Now if we start from the right side, see the triple bond is starting from the second carbon. When the locants of the double bond and triple bond from either sides are equal, you will give priority to double bond. I repeat, when the locant of the double and triple bonds are identical from either sides, you will give more priority to double bond than triple bond. So our nomenclature will start from the double bond end. So 9 carbon, non hyphen, 2 in, we will skip out E, 7 ine. Non 2 in 7 ine. Now moving to the structure. See, I have given two double bonds. So in that case, I'm going to use di-in. If it is more than that, tri-in, tetra-in, and the process goes on. The same process will be applied for triple bond, di-ine, tri-ine, and so on. So if we start from this end, see the double bond is starting from the second carbon. If we start from this end, the double bond is starting from 1, 2, 3 carbon. So we will give priority to the locant, least locant rule. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon, so NON. Next, hyphen. The double bond positions are 2 and 6. Hyphen, di-in, di-in. Now say, I've said that if your last part is starting with A, I, O, U or Y, you will never keep a vowel over here. But we are starting with the consonant T, so we will end with A. Moral of the story is that whenever you will get di-ins, tri-ines or anything more than one, if you get more than one double bonds or triple bonds, you will end with A. Always. So it's going to be alka. From alkene, it's alka. Then the suffixes, then the locants followed by di-in, tri-in, or whatever it may be. So the name of this compound becomes nona 2,6-di-in. Now moving to this compound. Now see, if we are having identical position of double bonds and any substitution, in that case, always give priority to double bonds. For example, suppose you have a compound something like this. If you have a compound something like this, we'll give priority to the double bond. See, 1, 2, it's starting from 2 and the substitution is starting from 2 on the right side. So we'll give priority to double bond. I repeat, whenever there will be identical locant of any substitution as well as multiple bonds, it will give always priority to the multiple bonds, whether it's double bond or triple bond, it doesn't matter. So 1, 2, 3, 4, 5, 6. We have methyl group, a single carbon is coming out from 5. So 5 methyl, 6 carbon, so hex, 2 in. 5 methyl hex to in. Remember, it should be continuous. They don't keep any space in between. So moving to this one, see 1, 2, double bond is coming from 2, double bond is coming from 2. In 3 there is no difference. In 4 position from either side, see we have nothing on the left side but we have a substitution on the right side. So we'll give priority to this one. I repeat, since whenever you have identical structures or symmetric structures, something like this, so try to find out the difference. For example, in the first position we have no difference, second point no difference, third point no difference, but in the fourth point, see we have nothing on the left side but we have a substitution on the right side. So we'll start from 1, 2, 3, 4, 5, 6, 7, 8, 9. So name of this compound becomes 4-methyl nona, because there are two double bonds, so nona 2,7 di-in. 4-methyl nona 2,7 di-in. Now moving to this compound. See, from the first position from either side, no difference. From the second position, we have double bond. We have nothing on the third position. Now on the fourth position, this is actually the point of difference. We have an ethyl group on left side and we have a methyl group on the right side. So in that case, we will give priority to the alphabetical order. E will come first. So 1, 2, 3, 4. So the name of this compound becomes 4 ethyl, 6-methyl, 9 carbon, so nona, 2,7 di-ene, 4-ethyl, 6-methyl, nona, 2,7 di-ene. Now moving to this compound. See, when you have this type of portion coming out from the main chain, this type of substitutions are called as methylidene. So, how to name it? See, no difference in the first point, no difference second point, third point no difference, fourth point no difference, but on the fifth point we have this methylidene portion on the left side. So we start a nomenclature from the left side. Five methylidene, then 10 carbon, so deca. Why we are using A? Because there is a double bond, two double bonds, 1,9 di-ene. So methylidene deca 1,9 di-ene. Now moving to the last compound. See, if you're provided with this type of branching which possesses multiple bonds in it, so see, if you start from this end, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and both are identical. See, we have double bond on the second position in these two branches. We have double bond in the second position from this side also. So we'll consider the longest chain, and that is this one. See, it is having 1, 2, 3, 4, 5, 6, and from 6 point, two identical branches are coming out. So we will be using this one as a parental chain. Now if we start for this chain, if we start from this, see, there is no difference in the first point from either side, second point no difference, third point no difference, fourth point no difference, but on fifth point we have a branching on the left side. So we'll start from the left side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Name of this branching, it's 5. Since it's starting from the point 5, so 5. Now calculate the total number of carbon present over here. 1, 2, 3, 4. So it's but 4 carbons. So but hyphen. We have now for this branching, we will always start from the carbon which is coming out immediately from the parental chain. This carbon is coming out immediately from the parental chain, so we name this one as 1, 2, 3, and 4. So 2 in, and see, this entire bulk is connected with the main chain by means of the first carbon. So 1 ion, 5 but 2 in 1 ion, and then the main one deca Ya, because there are two double bonds, 2,8 di-ene. So the name of this compound is 5 but 2 in 1 ion deca 2,8 di-ene. If you like my videos, please like, share and give your valuable suggestions. Please subscribe my channel. Thank you.